Alright, so we're going to graph a linear inequality in two variables. We're going to use some mathematical models, that's how things work, and we're going to graph a system of linear inequalities. It sounds hard, it's actually pretty easy, just follow the steps. So we're like 1, 2, 3, next thing you know you're finished. You will need some graph paper, you really need some graph paper for this. You can either spend some extra money, go to an office supply store and get some, or get some at mathbits.org or mathbits.com. You scroll down about 2/3 of the way, something about free graph paper on the right hand side, click on there and choose which kind of graph paper you want. That said, pause if you have to get the graph paper and then come on back. Alright, here we go. Notice that we have some extra symbols here, not just equals anymore, not just equals. At the end of the ax plus by equals c, instead of equals, we've got one of these inequalities. Some of them have equals, some of them don't. You know how that goes. If you work on the number line, the equals means you fill in the dot, and the ones that don't have equals means you will leave an empty dot. Well, we're going to do something similar with linear inequalities. That means we're going to have a line. Now here's a spoiler. Let me grab my pen here. Here's a fake line. Now notice first of all that I drew a solid line. That means that the inequality I had an equals somewhere in it. Let's put 32 out here, whatever it is. Now, to be a linear inequality, it just means something similar to on the number line, except we're on the Cartesian coordinate plane. So our graph is going to look like this. Everything on the line and to the right. The other linear inequality, for example, is one that might look something like this. Now this is one where you don't have the equals as part of it. So you have a dotted line that shows that the points on the line don't exist for your solution set. But the solution set will look like this. Everything to one side of that line. So there's a heads up. Let me clear the markers there for a second. Erase ink on one side. Okay. So we're going to change the symbol to an inequality, and we're going to play with that for a few minutes here. Let's see if I can. There we go. All right. So here are two examples of inequalities. One is right here. There's the inequality with no equals, and here's an inequality with equals. There are linear inequalities, two variables. Notice you have an x and a y, two variables. So the solution is going to be a set of ordered pairs, lots of ordered pairs typically, a whole region of points. So we're going to find which points satisfy the inequality. So here are some steps you can follow. Replace the inequality with an equal sign because we need that boundary point. In that first example I gave you, I created this line. Well, you're going to need a line like that, but you're going to need the equation to create the line. You'll have some x and y coordinates matched up. That'll help you draw the line. If you have the equals, make it a solid one. If you don't have the equals, then make it a dotted line. You got that? Or a dashed line, whatever you want to use. Next, and you're wondering, okay, which side do I shade in? Do I take that colored pencil, for example, and do I shade in this line, this side, or do I shade in the other side like this? Which way? Well, it says right here, and this is real easy. Pick one of those half sides called half planes. Any point at all. So if we've got a point like, or a line like this, that was one with an equals, right? And we're wondering, is this the right side? So we'll use some point that's easy to pick out. There's our test point. We'll take this point's coordinates, whatever the x and y are, we'll put it in our inequality, something like this, and see whether it's the right side or not. If this x and y work down here, then we pick the right side, and we'll shade that in. If it doesn't work on that side, then it means you picked the wrong side and you just shade in the other side. That is linear inequalities in a nutshell. And that's what I just said, number 3. So here's an example for us. So we've got 3x minus 5y greater than or equal to 15. Number 1 item. Notice there's an equals there. So when we draw our line, we're going to make it a solid line. Got that? Write it down, come on. So here we go. 3x minus 5y equals 15. We're setting it equal temporarily because we need to find that line. Now, where's the line? Well, I'm going to do it the easy way. First of all, I'm going to find the y-intercept. That's where x equals 0. And if I take that 3x minus 5y equals 15, set the x equal to 0 of minus 5y equals 15, divide by 5, negative 5, and y equals negative 3. So right off the bat, what have I got? Well, I've got x equals 0, y equals negative 3. 1 point. Very easy. Check. Now I'm going to find the x-intercept. That's where y equals 0. So I have 3x minus 5 times 0 equals 15. 3x equals 15. Divide by 3. X equals 5. So my second point is 5, 0. Now, if you want to be safe, pick another one. Pick another x, maybe a 2 or something like that, and figure out, use this equation to figure out what the y is that goes along with it. I'm going to stick with these two because they were so easy. I am really sure that I'm correct. So I'm going to draw a picture. Now this is a little bit careless perhaps, but I don't have any straight edge here that I can work with. So 0, negative 3. 0, negative 3 would be down here somewhere. That's my y-intercept. And the x-intercept is about out here, 5, 0. Those are my 2 points. Check back here. Yep, I'm supposed to make a solid line. So I'll connect those with a solid line, put an arrow at both sides. Now, the question is, does my graph look like this, or does my graph look like that? I'm going to check with a test point. And again, make it easy. Pick a point that is easy to work with. I'm going to use the origin, 0, 0. And I'm going to take my inequality, 3x minus 5y greater than or equal to 15. What I'm going to do is I'm going to see if 0, 0 is on the right side of the line. Am I going to shade in this side, see the point? Or am I going to shade in the other side? So 3 times 0, minus 5 times 0 greater than or equal to 15. 0 greater than or equal to 15. No, I picked the wrong side, so I'll shade in the other side. And that is the graph. And notice it not only includes this half of the plane, but it also includes everything that's on the line as well, because I had greater than or equal to 15. And there you go. That's how you work it. So here we go. There's the line, a little bit nicer this time. We got the x-intercept, 5. There we go. We got the y-intercept down there. Draw the straight line with some kind of a straight edge. And then they also use 0, 0 as our test point. And that one was false. So we shade in the other side of the line as well as the line itself. And there's a nice picture of what we have for a solution set. Next, let's look at this one. First of all, we've got y is greater than 2/3 x. So what I first need is an equation. Well, I need the boundary of that. Notice there's no equals there, so this is going to be a dotted or a dashed line. So first of all, the line that I need to draw is y equals 2/3 x. Okay, I need some points. Well, right off, if I put 0 in for x, I get 0 for y. So there's 1 point. Unfortunately, not only is that the x-intercept, but it's also the y-intercept. So I need another point. Well, what am I going to do? Well, this is pretty nicely set up, this equation. Excuse me. So all I have to do is pick an x, multiply by 2/3, I've got the y that goes along with it. And if you look at that, if I pick a multiple of 3 for my x, it's going to make the calculations a little bit easier. So let's suppose I pick a 6 for x. Then I'll have y equals 2/3 times 6. Since I'm working with fractions, I'll make that 6/1. I'll be able to reduce this a bit, and I've got the point 6,4. Okay, I'm ready to roll. So here is my graph. I've got a point for my line at 0, 0. I've got a point about 6,4 up here. This is 0, 0, and this is 6,4. Now I need a straight line, but wait, before I do that, I'm not going to have a solid line. So when I connect the dots with that straight edge, I'm going to make it a dashed line, and this isn't turning out too well, but you get the point. Make sure it's connecting 6, 4, and 0, 0. Now, which side am I going to shade in? That's a good point. So how about this point up here? Let's pick the point 5, 0 and see if that works. So I'll go back to my original inequality, and I'm going to put 5 in for x, 0 in for y. So y is greater than 2/3 x is my inequality. The y is a 0 greater than 2/3 times 5, which is 5/1. So what I've got is 0 is greater than 10/3, or 0 is greater than 3 1/3. False. Wrong side. This point right here is on the wrong side of the line. So I'm going to shade in the other side of the line, all of which will make it true. And there's the graph of my linear inequality. Let me get rid of the markings, the pen markings here, so you can see what's going on. There we go. They did it slightly different. It doesn't matter as long as you get 2 points that are on the line. And make sure you have that dashed line. See this dashed line we've got? Because it was a strict inequality. No equals are showing right there. They used the point 1, 1, and that turned out to be the correct side of the line. So this was the part that they shaded in with green. There's the test point 1, 1, and so on. Now some special ones. Graphing. Vertical line. Remember I mentioned this earlier? You might want to remember that. A vertical line here is one of those big threes for you. A vertical line has an equation that looks like this. X equals A, where you can put anything in for A you like. Also, you might want to remember that the slope of a vertical line is undefined. Now I'm getting ahead of myself a little bit, but this is a trio of information, all of which are linked. So for example, if you see the equation x equals 52, for example, you know it's a vertical line, and you know the slope of that line is undefined. Well, what's the flip side of that? Well, the flip side would be a horizontal line. Second, what would it look like equation-wise? It'd be y equals b, or b perhaps is a 53. And third, how about the slope? The slope is 0. Now these are not the same thing. First one has undefined slope. This one has a slope of 0. That does represent a number. The slope for the vertical line does not exist at all, whereas it does exist for the horizontal line. So for this one, where you had the line at x equals a, if it's greater than a, shade a half plane to the right of x equals a, because of the greater. If it's less than a, shade it to the left of x equals a instead. Remember, you're going to have a dashed line because there is no equals there. There's no equals there. And there's a picture of the two regions. This is the one, this is the side for x greater than a. This is the region for x is less than a. That makes sense, right and left, correct? Let me clear the pen markings for a second here. Okay. All right, there we go. All right, for the horizontal line, y equals b, you have a horizontal line, and you shade either above it or below it. But because it's greater than, you're going to shade above it. Above, greater than. That makes sense, right? If it's less than b, you're going to shade the half plane below y equals b. And there's a picture. This for greater than b, right here in the green. Less than b, here in the yellow. So how about a fast one here? First of all, let's take this one and graph it. First of all, the line associated with that is y equals -3. So let's suppose this is our coordinate plane. Y equals -3 would be a horizontal line, and it's down here. So here's my line. Now I draw a solid line because it's y less than or equal to -3. So make that solid so it looks different from the x-axis. There we go. There's our line. Arrow at both sides. Now, do we have it above the line or below the line? Well, this is less than, So it would be shading below the line, below and including the line too, remember. On the second one, our line is x equals 2. So what does that look like? X equals 2, that means it's a vertical line where? Well, 2 is over here. So you'd have a line that looks a bit like this, but since there's no equals involved, we'll put a dashed line or a dotted line here. Put an arrow at each end. Which side for that one? Well, it's greater than 2, so numbers over here would be part of our graph. Notice we have a dashed line or a dotted line because it's a strict inequality, no equals involved here. There's the first picture, over top the one we did, and the second picture. Next, once you've got that down, make sure you've got that down first. Otherwise, pause this video, maybe go back and watch again, maybe do a couple of exercises from the book, then come back here at about, 21 minutes into it, because we're going to move from just an equation or just an inequality to a system of linear inequalities. That means we're going to have 2 of those inequalities at one time. Now, here's a quick tip for you. This is how it's going to go. You're going to have 2 regions you're going to graph. So you might have one part that looks like this, and then you're going to have a second inequality. I need to change the color for this one, so let me change it to blue perhaps. Now you have a second line. Let's say the line looks like this, and the inequality for that one has us drawing in that region. Now for this system of linear inequalities, that is going to have a solution set where the 2 areas cross. So you take a third color and color in where both of those intersect. So you ready to go? Well, let's give this a shot. Okay, here's one, and we want to graph the solution set. So let's see. I'm going to do the best I can here. See if I can draw a halfway decent line. There's one, and across there, and let's just put some hash marks in. You usually don't because it takes up time, but it might be handy this time. And some more on the x-axis and some more on the y-axis. All right, now I'm going to go back to red temporarily. Red. So I'm going to work with this equation first in red. So first of all, I need the line x minus y equals 1 is a line. We need at least 2 or 3 points. So I'm going to pick some x's. I'm going to see what y goes along with it. So if I pick 4 for x, a 3 for y would get on that line. So over here at 4, up 3, there's 1 point. Second, let's pick another one. Let's pick a -1 there. So we'll have -1 minus y equals 1, minus y equals 2, y equals -2. So -1, -2 is another point. So -1, -2, there's another point. To be safe, you got to try another one. 0 is an easy one. Put 0 in for x. 0 minus y equals 1. Y equals -1. Okay, got 3 points. 0, -1. Sure enough, those line up, so we're in good shape. Now, what kind of a line do I draw? Let's go back here and see. It says less than, so I'm going to draw a dashed line. So as well as I can do that on this graph, there's about what my line looks like for the red inequality. Now I have to check and see which side I'm going to shade in with the red. So I'm going to use the origin. I'm going to test with the origin. Test with 0, 0. So 0 minus 0 less than 1. True? Yeah, that's true. So for the red line, I'm going to have the region up to the left. That's what one of my regions looks like. Okay, that's my red region. All right. Red for the first inequality. Now I'm going to switch to another color. And let's see, what do I choose? Maybe a green for the next one. So I'm going to make this one green. So I've got 2x plus 3y equals 12 for that line. Now notice the first one was strict inequality, so I had a dashed line or dotted line. This one will be a solid line because there's equals in there. So I need some points. Well, I'm in luck. For x and y, I'm going to let 0 for x. That'll give me 3y equals 12, y equals 4. So there's 1 point right away. 0, 4, 1, 2, 3, 4. There's 1 point on that line. Next one, I'm going to do it the easy way. I'm going to put 0 in for y to get the other intercept. So now I'll have 2x plus 3y equals 12. 0 for y, so I'll have 2x plus 0 equals 12. Divide by 2, x equals 6. So I have the point 6, 0. 1, 2, 3, 4, 5, 6. And there's another point. Now if you want to be very careful, get a third point. Maybe at 3, whatever it is. Check that out. It should fall on the line with those. Now, for this green line, remember I'm going to have a solid line because that equals. So I'm going to very carefully as I can, I'm going to draw a solid line connecting the green dots. There we go. Now ignore everything that has to do with the red part. Focus on the green. Now we need to test. Unfortunately, if you look at just the green line, we could test using 0, 0. So we'll go back up here to the 2x plus 3y greater than or equal to 12, and we're going to test using the origin. So 2 times 0 plus 3 times 0 greater than or equal to 12. True or false? 0 greater than or equal to 12. Well, that's false. So if we look at the green line again, I picked this point over here, and that was on the wrong side of the line. So what I need to do is color in the other side of the line. So very carefully, shade in the upper right part from the green line, and you should start to see where those two regions are going to intersect. Now I'm going to sneak back here and change the color again, and this time I know what I'm going to do. I'm going to use a highlighter. And what I'm going to do is where there are red lines and green lines, I'm going to shade that in. So I hope you can see this. This is the area that is in both those regions. This is the solution set. The graph of the solution set for that system of inequalities. And there you go. And before I go on, let me put that back. I'm going to change the ink color back to red and also back to the pen. So I'm ready to move on. All right. There's a pretty good example. It's a simple example, but it shows you the steps that you need to graph the solution set of a system of inequalities. And there are some of the steps we already followed. They use some of the same points. They use the intercepts because they're easy. And what they did was they took and found the x-intercept for both of them. I'm going to put this back to red, sorry. Pen. Ink color, red, there we go. Okay, I'm back to red, good. And they found the x-intercept for the second inequality as well. So we've got our two lines started. Then we do the same thing for both of them for the y-intercept for both of those lines or boundaries. Then we draw them. On the first one, we'll have an inequality, strict inequality, so that's going to be a dashed line for the inequality that this came from, and a solid one for that one. There's the first one, there's the second one. I'm not going to change the colors for you. And so this is what the first one looked like. There's what the second one looked like. And you can see that up here is where the two areas intersect. And that's where I put the yellow in the graph that I did. Well, I think that's a pretty good start. Try some on your own, and then bring some similar questions to class, some easy ones first for you, and then maybe some more interesting or complicated ones, and we'll work on those too. Well, until then, let's see what we've got. There's our overlap. This is with all the other places erased. We erased the extra part here, we erased the extra part here, so you could see that this is the region that graphs the solution set of that inequality, system of inequalities. And there we go. We'll see you soon. Goodbye.